be warned that sometimes your answer will be different, okay? So this is on page 33. If you're with me, have a calculator ready as well. You can do some calculating. So we're going to be working with kites, right? So we worked with trapezoids yesterday, and now we're going to introduce kites. By the way, triangles are everywhere. I don't know if you see it. Any shape that we're studying, you draw a diagonal, boom, you've got triangles, right? And so sine law, cosine law are still your friend. Pythagorean theorem, all of those things come with us. And I will ask you to not determine the value of angle WXY to solve the problem of it not working out if you use that angle. But where is this angle right here? Put your pencil on this angle just to review. Where would it be? You have your pencil there? Yeah, it's way at the top here, right? WXY. So it's this whole thing here that we would be wondering. But I will say omit, okay? Kite not drawn to scale, okay? So we will actually not use it. You can also write down, omit Mr. Dirksen made a mistake. You can say that too if that makes you feel better, right? Haha, I'm gonna take a mark off of you, Mr. Dirksen. How do you like that, right? -2 right there. Anyway, so obviously you realize this is a kite, and so we know immediately that these two sides are the same, and we know that, remember, it's two isosceles triangles stacked, right? Think of it that way. We can answer this real quick here before we start into the tricks portion of this. Determine the value of WX. They're just asking from here to here. I'm mostly interested in if you can tell that this is a stretch, right? So WX is 2 centimeters, boom. You got a free mark there. We're in page 33. And so I kind of sketched new kites here for us to do the work. So it's asking to calculate the length of WY. By the way, I'm building up my case for what's happening on the next page, okay? So WX, WY, sorry, this stretch, right? They're asking for this. And on the other one, XZ, so we go back to the original, which is this one. We also want to know this stretch right here. Okay. So transfer stuff over that you know. What do we know from the kite up here? Look at my pencil, right? 58 degrees. We know this angle right here. That's helpful. We happen to know that this is 3 and this is 3 as well, right? 3 centimeters the long sides here. So I'm going to call this Z, lowercase z, because it's a cross angle Z, right? So that's essentially the side I'm finding. Anybody know how I can do that? Which law can I use for this one? Cosine law. SAS, you remember that? Side, angle, side. Okay. Question. Pause me right there. Could you split this triangle and use Pythagorean theorem to find half of that stretch and then double it? You could, because this is a symmetric triangle. You can cut it in half. You cut everything in half, and then you could use not Pythagorean theorem, sorry, you don't know enough sides, but you could use sine law there because you have a pair 93. So keep in mind you could use another method. But let's go and find z. Okay, so z squared is 3 squared plus 3 squared minus 2 times 3 times 3, right? Because they're all the same sides. Cosine of 58 degrees. Z, grab your calculators, right? And find what that is. Find what that is and put it inside the root. I'm going to do that with you. So that's 9 plus 9, right? Because 3 squared is 9. Minus 2 times 3 times 3 times cosine of 58. Make sure your calculator is set to degrees, all right? Sometimes, for whatever reason, it gets switched to radians or something like that. Is that what you're getting? Yeah, that's what it is. So that's 8.46 ... So taking, oh, that's not what I wanted. Taking the root, let me just hit equals, and then I'll take the root of that. That's 2.91, because we're done. Like, that's what they wanted us to answer. So 2.91 centimeters is that green stretch, okay? So we know that that's 2.91. So that's that, okay? Now let's find xz. How would we do that? Do we know anything about it? You can either come from it from this side or this side. It's up to you. So if you go up here, we know that if this is 101, you know your properties, right? This is also 101, right? This is actually the only pair that is exactly the same, okay? So 101, 101. So you choose, I'm going to put it on this side, right? 101 is right there. 2 centimeters is right here, right? I'm copying it from the top here down. I'm taking the 3 here. It's an SAS again, right? I don't know if you see that. So we're going to do cosine law again. So what are we going to call that? Since I'm coming from this side, I'm going to call this side y. Okay, so to make it easier, you can also call it xz. That's up to you. Y squared, right, is equal to 2 squared plus 3 squared minus 2 times 3 times 2, right? Just take these two and multiply them here, times cosine of 101. Anybody remember what cosine of 101, what sign will that have? If you do this separately, this will give you a negative number, so you got to watch out, okay? If you're able to type this all in one shot, no worries there. 2 squared is 4 plus 9, right? Minus 12 times cosine of 101. I get 15.289, and that keeps going. So y is 3.91 centimeters. Okay. So you've got it. I used to teach this before I did trig, and it was so much more work because we had to split everything in half and then double it or whatever. This, just to make a point here, this is not an isosceles triangle. You got that, right? This is a 2 and a 3, right? So you can't say that. That would actually be, let's do some classifying, okay? It's classified information. X, Y, Z, that triangle is actually an obtuse scalene, right? And if you took this one here, that would be an acute isosceles. So with that, the top, I mean, we would have to know for sure. We'd have to do some more investigating what that angle is up there. But it could be done. Okay. Before I move on, I just want you to know how to do this part. I asked you to omit it to not add some confusion to this if you were to use this angle up here. But what do all 4 angles add up to in the for a kite or for any 4-sided? They add up to 360, right? So if you have 3 angles, you can easily find the 4th angle up top here if you wanted to. We're on page 33 if you just joined us. Let's keep going. So these two sides are going to be very important to me. I'm going to carry them with me. Okay, so let's go over to the second page. I need you to be very alert to what I'm doing here. Okay, this is important. Calculate the area of WXYZ, so of this kite. WXYZ is just the kite, right? Watch what I'm going to do here. Green was the long side, right? Or was it orange? What did I use for you guys? No, orange. So I'm going to just focus. I'm going to take this kite and let's make that orange line there. This was orange and this other one was green. And so you can, if you're careful, you can use any method you want, right? But which one of those diagonals is bisected? The orange one or the green one? Which one cuts in half? This one cuts in half. This is the long diagonal. It's actually always the short diagonal that gets cut in half. So we know that this from this corner to where the long diagonal cuts it, and the other side, these two stretches are exactly the same. Okay, short diagonal bisects. Okay, what else do we know about the diagonals? They meet at a 90. We call that their perpendicular, right? So there's a lot of things, right? Those properties help us out when we work with these shapes, not just to name them, right? So essentially there's 4 right triangles, but there's also, if you take the long diagonal, you have 2 triangles here, right? These ones, and one on this side. You could also argue that there's a triangle up here and a triangle down here. But watch what I'm going to do. I'm going to cut this kite in half here. So I'm going to use this to kind of replicate that, and I'm going to highlight that orange later on. Okay, so you can put Z down here, Y, X like that. This is the orange side still. We know what that was from the previous page, right? What was it again? 3.91? I look, yeah, this I calculated on the previous page. That's 3.91 centimeters. What's the height of this triangle? You ready for this? If I put that triangle on if this is my ground, then the height would be here, right? Measured from here. The height makes a 90 with the base. Is there a way I can find this stretch here? We know that from here to here is what? Can you say that again? 2.91 centimeters, right? So to get this to here, what needs to happen? Cut it in half. Yes, so we're going to divide that by 2. If your head hurts, that's okay. You're gonna have a chance to do this again. Height 1.455. So there's nothing different really for area of a triangle. Why am I using 455? Because that's not the end goal, right? To find the height. That's the intermediate step. So to find the area of this, area of that triangle, we would go base times the height divided by 2. So let's go ahead and do that. 3.91 times 1.455. All of that divided by 2. That's 2.844525 centimeters squared. How many of these do we have? Right, for the kite, there's 2 of them. They're exactly the same. Okay, so instead of dividing by 2, we'll go back to timesing it by 2. So that's total. So you grab your calculator, just take what you had, multiply it by 2. That's 5.69, right? If we round it, and that's centimeters squared. There it is. That's what we needed. So I did guide you through it, right? We found the 2 diagonals using cosine law. And why were they helpful? Well, this one isn't cut in half. So that's my base. But I used the shorter diagonal to find the height because I can easily just split that in half and get that number there. I'm not highlighting it green because that was for the whole diagonal there. Okay. And this is very important that the short diagonal bisects, and that's how I was able to do that. But I will show you a shortcut. Let me just see if it's... Yeah, it works. I just found out. So area of a kite, watch this. This is your shortcut. You ready for it? You take the long diagonal. You multiply it by the short diagonal. And you divide that by 2. Isn't that cool? Just find your 2 diagonals, multiply them, divide it by 2. Voila, you have your area for the whole kite. Should probably be on your study sheet. Hey, since we were highlighting, right, long diagonal times my short diagonal. You can try it out. Right, if you take the long diagonal is 3.91, multiply it by the short diagonal, divide that by 2, you get the exact same as we had before. So this is a shortcut to find the area. So you just need to have both diagonals, and then you're good to go. All right. Okay, so I'm going to ask you to go to page 35. It says you try, because I figured when I go through these, your head is going to spin a little bit, and you need to have a go at it right away. Okay, so go to page 35 and try this. I may not have done everything, right? But if you go to page 35, don't miss this piece of information right here. The diagonal AC is 10 meters. So we know something about this diagonal when it comes to properties, right? What happens to it. So use everything you know about triangles to answer these questions. So instead of an AC, this is your quote-unquote AC today, right? Give this a try. I'll do the attendance and then I'll go over it, but you need to give it a try. It's imperative for you to know how to do this. Okay. 5 minutes have gone by, so I'm gonna just quickly go over it. This should only be, if you did it, a review, right? So y we know is 7. So these are just easy, right? We know that this is 18 here, and we know that this is 7 there, so no surprises there. Okay, the diagonal, right? The diagonal there is 10, so that means that this is 5 and this is 5, right? We split that 10 in half. So if you want to find value of x, I'm going to use Pythagorean theorem, right? So this is 7, this is 5. Let's figure out x there. Use the bottom here, right? This is 18, this is 5, and this is p, right? So Pythagorean theorem will help you, and in turn you can technically figure out the long diagonal right there. If you know x and p, you have everything you need to find the long diagonal, right? So x is one of the legs there, so it'd be 7 squared minus 5 squared. That's root of 24. That gives you 4.89 something, which rounds to 90 centimeters, because it's actually asking for x, right? So we're done there. Oh, big difference, right? Yeah. And then for p, it's also one of the legs, so we go 18 squared, hypotenuse squared minus the other leg squared. This would be 299, right? And this would be 17.29 meters. Right, so now you have those two stretches. So again, it's not always exactly the same, right? But you got to know what can I figure out here. There must be a way to get me started, right? And it's the 10 that was actually the key here to get you going. Next, the value of ABC. I'm going to use a highlighter for that one. Angle ABC, I should say. ABC, it's this top angle here they're interested in. I don't know if you see that, but you have side, 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 right? We have, I'm just going to make a little sketch, 7, 7, this is 10. I want that angle there. You can call that B, right? You're with me? All right. So cosine of B is 7 squared plus 7 squared minus 10 squared. And this would be 2 times 7 times 7. And I get, when I type in the top, I get -2. What does that mean? It's obtuse, right? Yeah. 2 times 7 times 7 is 98. That in turn gives me -0.0208, I believe. Right? Something like that. So angle B is cosine inverse. This is great review for a trig. Okay, I like it that it's not going anywhere. We keep using it over and over. Okay, angle B is therefore 91.17. That's what I got. Okay, so now you know that top angle there. Calculate ADC. I'm going to use green for that one. Right, ADC. Where is that on the kite? Right, just follow it. ADC. Right, it's created. It's right here. These are not equal. Okay, these are not equal. Only these two are. They're connected by the short diagonal. Okay, so ADC. I'm just going to make a little sketch here. 18, 18, and the 10 across here. I can use, this is angle D in a sense, right? I can use cosine law all over again, and I'm going to cut this here so I don't mix them up, right? Cosine of D is 18 squared plus 18 squared minus 10 squared over 2 times 18 times 18. Cosine of D, if I crunch the top, I get 548. And the bottom gives me 648, which is 0.845, and it keeps going. I know that it's going to be an acute angle because it's positive. So angle D is cosine inverse of that. Right? And we have 3226 there. I designed these questions to get you through, like, thinking through all of these components and the properties, right? When I make these questions, I want you to walk through the properties basically and see them, right? This one should be easy. I put it in brackets, right? Angles A and C. Watch this. Look at my pencil. That's this angle here, the whole thing. We know that this is exactly the same as this. They are congruent. They're equal to each other. So watch what I'm going to do. It's similar to isosceles, but I'm going to say that angle A is the same thing as angle C. So I don't need to find them individually. I can just do it all in one shot. I'm going to go 360 degrees minus this one that I found here. That's the top angle minus the bottom angle here. So I take away the ones that I know, and what am I going to do with this remainder? Anybody? I'm going to divide it by, yes, I'm going to split it equally amongst the two remaining angles. So first do the top, 360 minus this, you get 236.57. You're smarter than you think, guys, honestly. Just trust your instincts sometimes. And that, if you split that in half, you get 118.29, okay? And so you can say angle C is also 118.29. They're both the same. Oops, you can't see that, can you? There, let me zoom in. There. The angles connected by the short diagonal are equal, okay? So it's very important in many ways, and you're gonna have to just go with what am I given already? What can I do with that? And to find everything else, right? It's like a puzzle. And then last but not least, we'll end with the area on the back side there, and it's still using this example, okay? CDE, and then F on the back side. Once you've written this down, go to 36 here. You're with me here, 36. So to find, remember, area is long diagonal, short diagonal. Basically, take both diagonals, multiply them, then divide it by 2. Multiply it by half or divide it by 2. That's basically what we're after. We know this one. I'm going to use this. We know this. Anybody remember? This was what? X, and this is P. We already found that, right? I set it up for you. So the long diagonal is X plus P, which is, I got to go peek real quick, 490 plus 1729. And let me just, even if you use cosine law here to find it, you should still get the same answer, or very close. So it's 2219. I'm just gonna underline it like that because it's important. I'm gonna just put in brackets C, B, right, on previous page. That's how I got these numbers. So area is therefore, the short diagonal is, this is 10, right? 10, and the long diagonal is already there, so 10 times 2219 divided by 2. It's actually just 5 times this, okay? You can go 10 divided by 2, that's 5 times this. $110.95. It could be that you got $110.91 if you use cosine law using these two sides to find the long diagonal. It's a little off, but we're not going to sweat it at all, okay? It's still okay. That is the area of this kite. So make sure this formula makes it to your study sheet, right? Area of a kite is found by going short long divided by 2. We have 20 minutes left. I think you should be able to put a little bit of energy. I know you don't have much left, right? But this is a short week. And if you consider quiz on Thursday, right, you need to make sure you're on track. So watch what I'm going to assign. I'm just going to go on my original here. So I'm going to tell you to try 37. So 37 to 38. I believe that you should be able to finish most of that today. And extra to start reviewing, right? I told you there's more than what you can probably, that we can cover in class, but this is a long shot, right? I would say this is already getting you ready for tests as well. It's not too early to try that. And if I have time, which I think I'll try my best, I don't know how my week is going to look like. I'm going to try to make videos for these ones. Okay, so if you're stuck, you just have to scroll through what page you need some help with, right? Because I know some of these are tricky, and you kind of want to know how did that come about? How did Mr. Erickson come up with that answer? So I'll try my best to do this, but I'd say this is today, and then this is like tomorrow, maybe for tomorrow a couple, right? And they go kite, trapezoid, all that stuff is there. All right, guys. So